So now we're going to talk about how to ID biomolecules or how to ID organic molecules or how to ID macromolecules. You'll hear those used interchangeably throughout the unit. And I've got a step-by-step process that we can use. This is just one of the ways. If you'll remember that standard 1.3, we need to be able to identify proteins, lipids, carbohydrates, and nucleic acids. And we need to be able to distinguish between them. So in this one, we're going to distinguish between the four different macromolecules based on or given a chemical or structural formula. So here we have, I'm going to go over the elements that each of the macromolecules contain. Remember we talked about four macromolecules, one being carbohydrates, and I'm just going to put carbs right now. And then we talked about lipids, talked about proteins, and we talked about nucleic acids. I'm just going to put Na right here. Okay, carbs contain carbon, hydrogen, and I'm sorry, that's supposed to be hydrogen, and oxygen in a 2-to-1 ratio, or 1-to-2-to-1 ratio. And what that means is for every carbon we have 2 hydrogen and we have 1 oxygen, okay? So for every 1 carbon we have, we'll have 2 hydrogen and 1 oxygen. Lipids also contain carbon, hydrogen, and oxygen, but they do not have a ratio. So they do not have a ratio, no ratio. Proteins contain, in addition to carbon, hydrogen, and oxygen, also nitrogen. And nucleic acids also contain carbon, hydrogen, oxygen, nitrogen, and they contain something that the rest do not, and that's phosphorus. So given this information, I've devised a chart to help us identify these easily. And this is what I came up with. When we talk about phosphorus, they only, or when we talk about nucleic acids, they only contain phosphorus. So when we look at a structural or chemical formula, we should look and see, does this contain phosphorus? And if we answer yes, then we know it's a nucleic acid. If we answer no, then we ask ourselves, is there nitrogen? Because that's proteins contain nitrogen. And if we say yes, then it's a protein. But if we say no, we look at the number of hydrogen and oxygen, because remember, carbohydrates have that 2-to-1 ratio, whereas lipids do not. And you count the number of hydrogen, and you're going to divide that by 2 and ask yourself, is there at least that many oxygen, or is the number of hydrogen equal to the number of oxygen? And I'll go through this and give you more examples as we go on. Okay, so this is a structural molecule, as you can see. And it says, what is this molecule? So we want to ask ourselves, is this a carbohydrate, a lipid, a protein, or nucleic acid? And our first question that we ask ourselves is there phosphorus? Now, is there phosphorus here? No. So then we ask ourselves, is there nitrogen? Is there nitrogen in here? No. So then we ask ourselves, how many, we have to count, how many hydrogen compared to the number of oxygen are here? So we'll count 1, 2, 3, 4. And then we have a 2 down here, so that means there's 2. 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 hydrogen here, okay? And then we count the number of oxygen. So we go 1, 2, 3, 4, 5, 6. Okay, so then there's 6 there. Then we look and we see, is this a 2-to-1 ratio? Because remember, carbohydrates have that 1 to 2-to-1 ratio, and we're just going to look at the number of hydrogen and oxygen in this scenario. So we look and we see, is this a 2-to-1 ratio of hydrogen to oxygen? And there's 12 hydrogen and 6 oxygen. So an easy way to do this, if you're not, great with ratios, is to divide this 12 by 2 and see if it equals the number of oxygen. So if we divide 12 by 2, we get 6. 6 is equal to 6, so the number of hydrogen is equal to the number of oxygen, and that gives us a So look back and we see, divide the number of hydrogen by 2. Is there at least that many oxygen? And we answer yes, so it's a carbohydrate. Now moving on to another one. We look and we say, what is this molecule? What is this molecule? So we have to ask our, series of questions. Is there phosphorus here? Is there phosphorus there? No. So then you go and you look and you say, is there nitrogen? And we look and we see, oh look, there's a nitrogen. So we can tell that this is a protein. Here we have another one. And this is just a chemical formula, so it should be really easy to distinguish. We ask ourselves, is there phosphorus? And there's not any phosphorus. So then we look and we see, is there nitrogen? And there's not any nitrogen. So then we look for the 2-to-1 ratio between hydrogen and oxygen. And we see that they have 34 hydrogen there, and they have 3 oxygen. So if we divide this number 34 by 2, that would give us, let's see here, 17. Is 17 equal to 3? No. So we know that this is a lipid. And a dead giveaway that there's a, I don't know why I did that. And a dead giveaway that this is a lipid is that there are much less oxygen than there are hydrogen. Now we look and we say, what is this molecule? In this molecule, we look and we say, is there phosphorus? And we can actually answer yes to this because there's a phosphorus nucleic acid. And a dead giveaway that this is a nucleic acid is that we have our three components here. We have our phosphate group, we have our sugar base, and we have our nitrogen base right here. You'll see those three units, or those three components of a nucleotide. Here we have what is this molecule, and it says what is this molecule, and we look and there's we ask is there phosphorus and there's not. So then we ask is there nitrogen and there's not. So then we ask, okay, so is there a 2-to-1 ratio here? So we have to count. And we see 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, 5 hydrogen, 6 hydrogen. We have a, ooh, that's way up there, a 6 to 2 oxygen here. Is that a 2-to-1 ratio? So we divide this 6 by 2, and that gives us 3. 3 is not equal to 2, so that means it's a lipid. Okay, I think that will help you identify macromolecules, and if it doesn't, then we have office hours where we can go over these together.